talk about this review sheet, and again, this will be on the test, that's why I want to go over it. You'll have this same identical table or graph, whatever it is, chart. Along the y-axis, we have some interesting units that says grams of solute for every 100 grams of water. Now, when we talk about grams of solute, is solute the thing that's being dissolved or doing the dissolving? Being dissolved. So it's our, in most cases, this represents for a lot of solids or salts. Okay? And then along the x-axis, we have our temperature, which goes from 0 to 100. Again, we're working with our solution here, so we're not going to get it too much higher than that. But generally speaking, as you look at the data, going from 0 degrees Celsius to 100 degrees Celsius, and again, this is a solubility chart. And what does solubility deal with again? How well something dissolves or dissociates in water. So generally speaking, do things increase their solubility as the temperature goes up or decrease? Increase. This is an increase. In other words, like looking at this bottom one here, KClO3. I'm assuming that's a 3. I can't really tell if that's a 3 or 4. We'll assume that's potassium chlorate. So at 0 degrees, we have about 4 or 5 grams that can dissolve at 0 degrees. However, at 100 degrees, we can get almost 60 grams to dissolve. So as you increase the temperature, you increase the solubility for most things. Now, when we talk about gases, what happens to that solubility? Does it increase or decrease? Decreases. That's why we want to drink our colas cold, because we want to keep that carbon dioxide in the solution. Now, there is one thing that actually decreases as the temperature increases, because we're treating this as a gas. Okay, so as the temperature increases for gases, they have the inverse relationship, or how well they dissociate or dissolve in a solution. So let's go through these. Okay, so number 1 says, which salt is least soluble in water at 20 degrees? So find 20 degrees, and when you talk about least soluble, are you looking for something way up here or way down here? Way down. So whatever that is, KClO3. Okay. Number 2, how many grams of potassium chloride can be dissolved in 200 grams at 80 degrees? Well, again, recall that this is grams of solute per 100 grams of water. If we double how much water we have, so let's do this first. Potassium chloride at 80 degrees. So 80 degrees, where's potassium chloride? Right here. So how many grams of potassium chloride can dissolve in 100 grams of water at 80 degrees? 50. Okay, so if you have twice the amount of water, how much can you dissolve? 100. Okay. So if you double the amount of water, you can dissolve more stuff. All right, so 100 grams should be of the potassium chloride. Number 3, at 40 degrees, how much potassium nitrate can be dissolved in 300 grams of water? So pretty much the same thing here. So we have our potassium nitrate at what temperature? 40. So potassium nitrate, where are you? Oh, it's right here. So what would you say that is? 42, 43. So somewhere in that ballpark. We'll say it's 42. If we dissolve it in 300 grams of water, how much total can we dissolve? 3 times 42. 126? Okay. So I'd accept something between 126 and 130 or 132, somewhere around there. So everybody getting it? Makes sense? All right, number 4, which salt shows the least change in solubility from 0 to 100? So we're kind of looking for one that's almost plateauing. Which one is that? Good, sodium chloride. So it almost forms a flat line here, but it is increasing gradually. Okay. Let's look at the next one. All right, number 5, at 30 degrees, 90 grams of sodium nitrate is dissolved in 100 grams of water. Is this solution saturated, unsaturated, or supersaturated? Well, let's do this first. Let's go to the 30 grams and 90 grams of sodium nitrate. So, I'm sorry, 30 degrees and 90 grams. So here's sodium nitrate right here, the curve, and 90 grams is just below the curve. Now recall back to when we lectured about saturated and unsaturated. If we have, like the iced tea, using my wife again, if I pour the packets of sugar in there and it dissolves, what is the solution? If it'll dissolve it. It's unsaturated, because it can still dissolve that out. If I pour the packets of sugar in there and the crystals just fall to the bottom, what is that?
Unsaturated.
Saturated. In other words, it can't dissolve anymore. So up to the curve is considered unsaturated. Or think about this. Under the curve, unsaturated. Okay? So if we have 90 grams at 30 degrees, have we hit the curve yet for that temperature? No. So this is unsaturated. If we had, I'll say that it intersects at 92. If we had 92 grams, we would say that it's saturated. And you add any more of that, the crystals will fall to the bottom. So above that would be considered supersaturated. So under, on the curve, or on the line, saturated, above the line, supersaturated. Okay?
What would that look like?
Well, what look like?
Like if you had something that was supersaturated.
It would just fall. It would fall to the bottom. So this is just giving you what your level of saturation is at that point. I'm sorry.
What was the answer to
Number 3.
No, number 4, sorry.
Number 4. Oh, sodium chloride, NaCl. Go ahead.
So unsaturated is below the line, supersaturated
Or under the line. Okay. Saturated is on the line or on the curve.
And this is at 90?
Wherever.
30.
Wherever it's at your
This
coordinates.
problem. This is at
Yeah, so for this one it's 30 and 90, which is under the curve.
Is that over?
Nope. Here's the curve right here. It's under. 90's right here.
Oh, so you're
So
not talking about the curve.
The curve, yeah. The curve for the respective salt.
Okay. So
Or the
you're
respective
talking
thing.
about the grid itself is under the curve.
The intersection point,
Yeah, the intersection point.
90 and 30 is below. Yes.
Right.
Okay.
What if it's on the line?
If it's on the line, who can answer that?
Saturated.
Saturated. What if it's above the line?
Supersaturated.
Super. Okay. All right, number 6. All right, this is how rock candy's made, and you can do it with other substances as well. It says a saturated solution of potassium chlorate is formed from 100 grams of water. In the saturated solution, if the saturated solution is cooled from 80 to 50, how many grams of precipitate are formed? Okay, so we're looking at potassium chlorate, and we go from 80 to 50, so potassium chlorate's right here. So at 80 degrees, how much potassium chlorate can we dissolve? 40. So we have 40 grams. It says it's saturated, so it's right on the line. If we lower the temperature from 80 to 50, how much can I then have in solution? 20. So if you have 40 grams of the potassium chlorate in solution as ions, and then the temperature cools, 20 of those grams are going to come out of solution and form crystals on the bottom. So how much of the precipitate is formed? 20 grams. Okay, so 20 of the grams of potassium chlorate stays in solution, the other 20 makes crystals. And that's how rock candy's made. You heat up water, put a lot of sugar in there, let it melt, don't put too much in there, and then slowly let it cool down, and that sugar comes out of solution and forms some nice crystals. Makes a mess, but still makes crystals. All right, number 7, what compound shows a decrease in solubility from 0 to 100? So as the temperature increases, which one decreases? The ammonia, the NH3. So it's the only one on here that decreases. And it's safe to say that that's acting as a gas. Okay. All right, number 8. Which salt is most soluble at 10 degrees? Which one's most soluble? Here's 10, even though they didn't put it on there. Ki, which is potassium iodide. Okay. So the highest or the greatest solubility is the one at... Yeah, most. Let's see, number 9. Is that where we're at? Which salt is least soluble at 50 degrees? Okay, so potassium chlorate, right? So look, is it 50 degrees? Yeah, 50 degrees. So find the 50, whichever is lowest. So potassium chlorate. And which salt is least soluble at 90 degrees? Now this is a trick. I'm going to be honest with you. Don't pick NH3. It's NaCl. Okay. Because the other one's a gas. Now I won't be that cruel to you on the test. Or maybe I will.
And what was the track?
What's that?
NH3 is a gas.
Yeah, NH3 is a gas, not a salt. And think about salts as ionic compounds that when you place it in water will dissociate. And everything on this chart will dissociate in water except for the NH3, which ammonia doesn't.
Wait, can you go over number 6 again?
Number 6. Okay? So we go from, we have a saturated solution of our potassium chlorate. So again, at these respective temperatures, that is saturated. In other words, we can't hold any more of the ions in solution. So if we go from 80, which how many grams can we dissolve in there? 40, yeah, KCl3 here. So how many grams? Goes from 80, means we have 40 grams. And if I cool the solution down from 80 to 50, how many can I now?
40 to
40
20.
to 20.
Does that mean it's 20 grams?
20 grams remains. Or will form crystals. Let's do another one that's not on here. Let's say we're looking at potassium nitrate. That's a good one. Let's say we go from, let's find a nice intersection. There we go. 60, say we go from 60 to 30. How many grams of crystals will be sitting on the bottom for our potassium nitrate? So we go from 90 to 30, so 60 grams, approximately, yeah.
Bam.
Okay.
So you minus it?
Yep, take the difference of the two. And that's how much will precipitate out. Okay. All right, the other worksheet, I want you to work on it in class. And again, it combines all the packet, both parts of the packet. So some of these questions are intermixed. Some of these are very, very recent to what we just talked about.
Do we need the lemon chart with